This is digital signal processing lab number 2. We'll take a look at what are the functions that we are going to use in here. Basically there are two functions, right? And I will recall the previous use functions as well. So first one is convolution conv, and the arguments are x1, x2, string called same. So this will return only the central part of the convolution. So it is the convolution between x1 and x2. Then it will return the same size. Same size means size of x1 convolution values. So here what you have to understand is x1 is the signal 1 and x2 is the signal number 2. We have to define previously, right? And y will be the output of conv. So this is very much easy to use, and if you want to understand this further without applying into here, first you can apply it to two random signals. Before applying into this lab, you can apply it to two random signals in order to understand what it does. Then next one is the subplot command. In subplot command, there are three arguments, m and p. Right? So what it does is it will break the figure window into m by n matrix. M by n matrix means m number of rows and n number of columns. And when we write, when we select, and it will select the pth axis for the. That means, as an example, let's say we are running subplot 311. What it does is first it will divide, or it will divide the uh, figure window by 3 by 1 matrix. That means 3 rows and a single column. So 311 means p value is 1. That means it will select the first value or first figure as the first one as the figure for that relevant plot. So this will consist of two parts. One will be the convolution and the other one will be the convolution properties. So we'll take a look at the first question. Perform the convolution of the two signals x1n, that is 0 1 1 1, and in red color that is the value at n equal 0. X2n is equal to 1 2 3, and 2 is the value at n equals 0. Then you have to perform the convolution within n equal -5 to n equal +5. So basically what we are doing in here is first of all you have to define n, right, from -5 to +5. Then you have to define x1n, and when you are defining x1n, you have to make sure that 0 value is at n equals 0. And likewise, when you are next thing is you have to define what is x2n, and when you are define x2n, again you have to make sure number 2 is at n equal 0. So after defining n, x1n and x2n, what you have to do is you have to apply the convolution. So convolution will can be applied using conv command in MATLAB. So you when we are using conv command, first of all you have to write in the arguments the first signal, which is x1, then the next signal x2, then you have to write down the shape of the signal. So what you can write is, you can write it as the same, so that is a string. Then in order to find out, or the no or in order to summarize what we have done, what you can do is, you can write down, or you can draw the stem functions of x1, x2, and the resultant, which is the convolution of x1 and x2. Question 1.2, right? So again you are asked to perform the convolution, right? And xn and xn values are given. So what you have to do is, first of all you have to define values of n. Then you have to define value of you have to define xn function. Then you have to define hn function. Then using that conv command, we can find the convolution. And using the stem command and the subplot command, and also you can label the x-axis and the y-axis. So by doing that, so you can draw all three plots, that means xn, hn, and the convolution between xn and hn in the same plot. Question 1.3, again you were given the x value and the xn and hn, right? Again, first of all you have to define n, simple n, then you have to define what is xn, and then you have to define hn. And now again you have to make sure that the highlighted values are at n equals 0. So we have done that one in the previous lab class, so therefore use it in here as well, right? And after defining xn and hn, you can apply this that convolution function. So afterwards you can draw all three figures in the same figure using the subplot command. So most of the things are like very much equal to the previous one that we have done. Next one is again the same thing, but it is defined differently. Two signals, right? X1 is minus 1 to the power n multiplied by un plus 1 minus un minus 2, right? So this is the unit step function, shifted versions of unit step function. In previous lab we have learned how to shift the functions, and therefore you can use it in here. So what you can do is, you can first define what is un plus 1, right? Then you can define un minus 2, un plus 1 minus un minus 2, that you can multiply by minus 1 to the power n. So use the exact method that we have learned previously. And x2n, that is 2 into delta n plus 1 minus delta n delta n, right? So actually what this says is 2 into delta n plus 1 means 2 is the value at n equal minus 1, and minus 1 is the value at n equal 0. So what you can do is you can either write x2 in terms of the discrete value. So in here x2 n is represented as a weighted sum of unit impulse, right? Unit impulse, shifted versions of unit impulse. Or what you can do is, first of all, you can write down x2n is equal to um, 2 when n is equal to 1 is equal to minus 1, n is equal to 0. So likewise you can define what is x2n as well. Then you can perform the convolution. And again you can draw x1n, x2n and the convolution of these two. So we have learned how to perform the convolution. So exercise 1.1, this is for you. So you have to perform the convolution of the two signals xn and hn. So you were given the range of n from -7 to +7. So this exercise you have to do it by referring the previous examples. Then example 1.2, in here again you have to perform the convolution of the two signals x1n and x2n. So you were given what is x1n and x2n. So there and the range of n as well. So using the previous examples, again you can do this exercise. This is also an exercise for you. So here x1n and x2n are defined as functions. So we have done one example like this in a previously. So referring that one, you can do this. Again, what you have to do is in here is x1n. First define un plus 2, then un minus 3 by shifting un. Right, so as we have learned in the previous lab, then find out un plus 2 minus un minus 3. Then you can find out what is x1n by multiplying it by -1 to the power n, right? Then you can define what is x2n, and afterwards you can perform the convolution between x1n and x2n. So you have to draw the three functions as well, x1n, x2n and the convolution between this with the proper labels as we have done previously. So this is the this part is the second part of this lab, convolution properties, right? So I will explain what is happening in here. So you are given xn and h1n, right? So xn is equal to -2, 0, 1 and 0 is a value at n equals 0. Then you were given h1n. H1n is given as weighted sum of shifted impulses, right? Then h2n, that is also given as weighted sum of shifted unit impulses. So again again if you want to find out what is h1n and h2n in terms of in terms of the values of n, right? That means what is the value of h of n when n is equal to 0, when n is equal to 1. So likewise you can find out, and in here what you are asked to do is you are asked to estimate HEQN, right, and YN. So YN is equal to XN convolution HEQN, right? HEQN. So what we are going to do is, so refer the figure below, right? Refer the figure below. First of all, we'll refer the figure below. So in this figure, what you are given is, so there are two diagrams where, so we'll refer the first one xn, that is feed into h1n and h2n two systems, right? Then the output of H1n is Y1n, output of H2n is Y2n, right? And and the total output will be Y1n plus Y2n, right? Y2n. So then refer the figure below, the next figure. So in here, your input will be Xn to HEQn, right? HEQn. Then the output will be Yn, which is equal to Xn convolution with HEQn, right? So what is in here H1 Y1n? Y1n is Xn convolution with H1n. So then what is Y2n? Xn convolution with H2n, right? And the total output will be the addition of Y1n and Y2n in the first figure. Then in the next one, what is this HEQn? So if you can remember, I have told you that in here this is actually the parallel connection. That means you are feeding X into H1n and H2n both, right? So HEQ, that means the equivalent transfer function that can replace H1n and H2n will be HEQn, right? HEQn is actually, it is H1n plus H2n, right? H1n plus H2n. So when we have HEQn as H1n plus H2n, what we are getting is Yn equal Xn convolution with HEQn, right? So what we are going to do in here is we are going to see whether Y1n plus Y2n is equal to Yn, which is so like that. So what we are going to see in here is whether Y1n plus Y2n is equal to Yn or not, right? So in here what we are doing is actually what we can do is you can first define what is Xn, right? Then you can define H1n, then you can define H2n, right? Then by convolving Xn with H1n you can find Y1, right? Then convolving Xn with H2n you can find Y2n, right? Then adding Y1n and Y2n together you can find Y1n plus Y2n. So that is our first result, right? Then next one is you can find HEQn by adding H1n and H2n, right? Then convolving HEQn with Xn, or convolving Xn with HEQn, you can find Yn, right? Then you can see whether the results are equal or not, right? So after finding Y1n plus Y2n, you have to draw it. Then you have to find Yn, and you have to draw that one as well. Then what you can do is you can observe whether those are equal or not. So in this one, question 2.2, we'll refer the below diagram first, right? So in here what you can see is in the first figure Xn is the input to H1n, then what you are getting is Y1n as the output of H1n, right? Then so what is Y1n? Y1n is the Xn convolution with H1n, right? Then the resultant, which is Y1n, we are feeding it to again H2n, right? So when we are feeding it to H2n as the input, the output will be Y1n convolution with H2n. So together we have got the um, output, right? So I'll explain again. When we input Xn to H1n, you will get the output as Y1n. And when you feed Y1n to H2n, you are getting the output as Y1n convolution with H2n. So somehow xn has gone through H1n and H2n both, right? Because Y1n is also going through H2n, right? So therefore the resultant will be Y1n convolution with H2n, right? Then refer the next one. So in there, xn is fed into HEQN. HEQN is the uh, HEQN is the resultant of H1n and which can replace H1n and H2n, right? Actually HEQN will be the convolution between H1n and H2n, and HEQN will be the convolution of H1n and H2n, right? So then we are feeding xn to HEQN. The output will be yn, which is equal to xn convolution with HEQN, right? So in here what you have to do is you have to check whether y1n convolution h2n, right, is equal to yn, right? So since h1n and h2n is replaced by heqn, right? So here you were given xn, then h1n and h2n. So what you have to do is, what you are going to do is first you will find y1n by convolving xn with h1n, right? Then by convolving y1n with h2n, you can find the total output of first system. So that is our first result, right? Then what you are doing is you will convolve h1n with h2n, then you will find heqn, right? Then you will find the output of heqn by convolving xn with heqn. Then you can find out whether the two results are equal or not, right? So it will be shown graphically. So therefore what you have to do is you have to draw that thing, okay? This is example 2.1. This is a exercise that is given to you, right? So before referring to the signals, I will refer the two things figures below, right? So in first figure you can see xn is fed into h1n and h2n, so you are getting y1n and y2n, right? Then that thing will be fed into h2 h3n, then you are getting the output, right? So the output, so the input to h3n is y1n plus y2n, right? So input to h3n is y1n plus y2n, right? So then what you are doing is, by using your previous knowledge, you are going to find what is HEQN, right? So here you will have both parallel connection and the cascade connection that we have seen in previous uh, examples, right? So what you have to do in here is, right, you have to find out y1n by convolving xn with h1n, then y2n convolving xn with h2n, right? Then the addition of that, which is y1n plus y2n, feed it to h3n, then find the output of that thing by convolving y1n plus y2n with h3n. So that is our one result, right? Then in next one, what you have to do is, actually you have to find out what is HEQN from the previous knowledge that you have, right? So there will be like H1 and H2n is in parallel, and that part will be in series with H3n. So therefore find out what is HEQN, right? So HEQN, then you can check whether your yn is equal or not with y1n plus y2n convolution with h3n.